Hello. Hi. Hi, front row. Okay. I'm Victoria Adeyeri, and I'm a software developer from DNEG. This is my colleague, Ian Abbott.
Hello.
And he is a software architect at DNEG. And we're going to tell you about some of the problems, or problem spaces, I'm supposed to say, that we have at DNEG and how we're using Red Hat's tools to solve those problems. So, as you can see from the show reel, at DNEG we create visual effects for TV and film. We also do virtual production, feature animation, and immersive experiences, which is basically theme park rides. At DNEG, we have thousands, roughly 9,000 staff across the globe. Sorry. There we go. So we have many staff spread across many different global sites, and that staff is made up of artists and developers, and they're all using lots of different types of software because, in case you didn't know, in the VFX pipeline, when we're working on a show or a film, the work goes through different stages, through different teams, and each team usually has some kind of specific software that they like to use to do their specific task. So often they'll be importing data, doing their bit of work, exporting it, it goes to the next team imports it into their important software that they use, they do their work, and so on until it reaches the end of the pipeline and we have a finished product. So one of the issues that we have is all that different software can get kind of complicated. So across the VFX industry, we have started to use universal scene description, which is a new file format created by Pixar. And that file format is able to be shared across all those different teams and all the different types of software that they use. So it speeds up some of the process of making the final shot, because it means that different teams can work on those different bits of data at the same time, since you don't have to do the exporting, importing, or conversion, or whatever. So one of the issues with USD is that it has increased the complexity of the data that we store. Because USD, it's similar to, if you used Photoshop before, it's similar to that in that it has layers to the file. So as the data is passed to each team, they can add their work to a separate layer in USD. So for example, somebody's made a model of a car or something, but you want to make the color of the car or the surface of the car, it goes to the next team, they do that work. But that's just a different layer in the same file now, rather than different files kind of smushed together at the end. And we're using OpenShift to help us kind of move into this new paradigm of using USD. And so the data that we use now in USD, it's about 8 times more complicated than whatever the previous data was. That's what we've worked out. So it means a lot more data has to be stored, and it means the pipeline is slightly different than it was before. So to manage all this data across all the teams, we have what we call the digital asset tracking system. And this is where we store all the different characters, buildings or vehicles that make up what we call assets, and that make up all the different individual pieces of the scenes in all the films that we make. So we have an example of an asset breakdown to show you. Here is an example of a breakdown. So you can see in this little sequence, we have modeled vehicles, we have destruction simulations, we have volumetric effects, we've got robots, and all the different pieces that you see, all the little bits, they're all separate little tiny assets. We have to store the assets themselves, we have to store the relationships between all the different assets, and again, this just forms like a huge amount of data that we have to store and has to be readily available for the artists so that when they finally finish rendering a shot and send it to the director for him to say yay or nay on it, If the director says, can you change just one little bit, maybe make that truck red, or make the robots look a bit scarier, I don't know. It has to go back to the artists. They have to make their changes. We have to re-render the shot, and so on. So again, we're kind of reusing that same data. You have to be able to pull it up quickly and recreate it and send it out again. The asset tracking database is used, as I showed in the previous, one of the earlier slides, by artists across the globe. So you have many different artists and developers all trying to connect to this database information all the time. That means lots of different, potentially many different database connections, different queries being made per minute. And we are currently using OpenShift to help us manage the newest version of the asset tracking system, because you'll find that within the database we have a little over 100 million unique assets and around 1.5 billion relationships between those assets for us to save. And so the latest version of the asset tracking system has been deployed via OpenShift. We have clusters in all those different locations across the globe, and now those queries are being managed through that, and we're able to actually keep track of how many queries are being made, where they're being made from, how many queries per minute, and this is all being done through kind of OpenShift logging and Grafana, and is helping us track that information. This is a graph showing some of those queries going through the system. So if you see the big line at the top, that is one specific show, and this is showing 200 million queries being made just on that one show, and then all those little tiny lines, those are the other shows that are not being done in USD. So the top show with all the millions of queries is being done using the new USD pipeline, and the other shows are not and have like much less complicated data. And then the graph at the bottom is showing that most of those queries are coming through our Montreal OpenShift cluster, and then maybe Mumbai is the next biggest, the next biggest cluster, and then all the other ones. So this one show, obviously, is taking up 90% of all the resources. So we had an idea that maybe we don't want that to happen every time we have a big show. So we thought we would put in some rate limiting so that for future shows and the other current shows, they won't be stealing the resources from all the other shows that are being made. In this case, though, because this is a critical show, sorry, I'm not allowed to tell you what the show actually is, but because it's a business critical show and it's near kind of end of production, so it's almost time for us to send the finished product out to the studio. We're not going to do any rate limiting on that show, but all the other shows, all the other smaller lines at the bottom, they can have limits of between 10,000 to 50,000 queries a minute. When we're going to do new shows, and we're going to do bidding for a show, what we're going to do is split all of our shows into these 5 categories, and that's how we're going to manage the limiting. So, as I said, we're going to have limits of 10,000 to 50,000, so category 1 show, 10,000, category 5 show, we're going to set it at 50,000. And this limit, this category even, is going to be based on the complexity of the show. So the complexity, we'll say, is either due to how many shots are in that show, maybe how hard those shots are going to be to create, or even just if we have to develop new technology to work on that show. Once the category is set for the show, it probably won't change for the duration of the show. Because we'll use that information to basically work out how much we think that show is going to cost us, and we use that in our bidding process. Right. Now I'm going to hand over to Ian, who's going to tell you a little bit more about how we actually implement that rate limiting.
Oh, cheers, Vicky. 3Scale. What I'm going to talk about very quickly is the kind of the what, the why, and the how. So firstly, what is 3Scale? So if you're not familiar, 3Scale is Red Hat's API management platform. We're using it because we're pretty much into the OpenShift ecosystem. We've got ACS, we've got ACM, we're using GitOps and pipelines. So 3Scale fits in really well with what we need, and also because we do things for film and television, we are air-gapped. So that means that we can't easily connect to things on the internet. So 3Scale here, what you've got at the top is you've got the management plane. So that consists of the main system with the key value stores and the databases. And that also comes with an admin UI for managing the system. And it also comes with a developer portal. And that's used to effectively give you your client-facing APIs. So you can see your documentation for your APIs. And you can also subscribe to application plans with keys. And on the bottom, we've got the API gateway. That's installed via another operator, and that handles the traffic. So what will happen is an application will do a request. It will give the credentials for the key. The gateway will then effectively contact the plane with the route and the key. The plane will then say, yes, you're allowed to see this. If it's allowed, it will then be passed through to the back end, and then the rate limits will be adjusted accordingly. Now, as part of this actually happens asynchronously. So the application is actually sending the data directly to the back end and not through the plane. It's really useful for us because as we're global, we don't want a disconnection at any point. So what will happen is that if the network goes away and we can't contact the plane, we can cache the credentials so that we can carry on talking directly to the back ends. And also, because we have so many API hits coming in, what we can do is we can batch report back the metrics. So rather than doing it on every single hit, we can do it every 10 seconds, every 20 seconds. So also, with 3Scale, we've got these definitions. I'm not going to read them all out. You can kind of see them there. The basics is that 3Scale has products. These are bundles of backends. And then we have the idea of the application plans and the applications that then talk to those products. So normally, you'd configure 3Scale using the admin UI. However, recently, they've added the capabilities operator. So what this allows you to do is configure it declaratively using YAML, which is very good. So we can do GitOps. We can put everything in a Git repository. We've got that audit tracing. We've got the visibility. There are some caveats, though. Effectively, if you're doing GitOps, you can't then use the admin UI. This is because you'll either have your changes overwritten, or if you do something destructive, you can end up in a slightly unknown state as it tries to work out whether that system already exists. So, how do we actually handle the asset tracking? So, the way it works at DNEG is that because we're all over the place in terms of sites and shows, each site actually has its own set of assets and shows that it can deal with. So we don't have one API that's the same everywhere. So we already are deploying that via Argo CD and Customize, where in each cluster that we have, we're deploying an in-service cluster local version that is dedicated to its own database and its own shows and its own assets. We need to replicate this in 3Scale. So again, what we do is we declare the base, and we say that our endpoints, such as health info and our actual API query point, and then we have that in-cluster version mounted on the root of our product, because most of our queries will be for that site. But our developers also wanted the ability to explicitly query from any site to any site. So what we do is we use Customize, and this will then just render out a manifest of all the different versions. So they'll have the public root APIs of those particular objects, and those will then get mounted into the product as well on different site codes. With those in there, we can then do the application plans. So with the application plans, you can actually do rate limiting in different ways. You can do them on the back end, you can do them on the product level, or you can do a mixture of the two. So for us, we're just doing a simple thing where we're just doing it on the product at the moment. So we have our categories 1 to 5, which have the 10,000 to 50,000 queries per minute, and that is spread across all of those routes. So if you're on the 10,000 query plan and you did 5,000 to LUN, you'd have 5,000 left spread across those other routes. In addition, you'll see we've got the thing at the bottom of the question mark. So normally, if you don't have a key, you're denied access to everything. But what we can do is we can put a default key And when you connect, it will put you on the application plan, but a very, very limited form. So then we have the configuration. We've already covered that we're doing the products and the back ends via GitOps on the left using Argo. But for the application keys, what we do is we're actually using the developer portal on the right. There's a couple of reasons for this. The first is that when you do an application CRD, it's linking the application to the product, but not the key value. And that's because you don't really want to have the key value in Git. And the second reason why we're using it is because of the show flexibility. Shows are coming and going, and we don't want our developers to have to do pull requests for every single show that comes in. So to manage that, we move the database from 3Scale outside of the cluster so that we can keep a backup of it with our core systems. Finally, we have the idea of the API management plane and the gateway. Normally, we'll just have probably one plane, one gateway, maybe some replicas. What we have is we've actually got gateways in every single site. And the way this works is they're all operating independently, and they're communicating with the in-service versions. There's also lots of invisible arrows connecting all of these together. But in terms of 3Scale, it sees all of these independent gateways as one thing. So again, if you've got the 10,000 requests per minute, that applies wherever you are. So regardless of the URL you're on, you're going to get rate limited. Beyond that, we've got a few further tweaks that we're looking at. You have the idea of multi-tenancy. This is where you can actually shard the 3Scale database into like development and production instances so that you can change things without impacting production. And we also have the edge limiter. So the edge limiter is a gateway policy that allows us to control concurrency, say 1,000 connections simultaneously. It also does requests per second, because 3Scale by default goes from the minute to eternity level. And finally, what we can do is we can commingle things that are in the request packet with the application keys. This is mainly if you've got a client that's got an application ID and another client with the same application ID because it's on the same show, and you don't want one client to be greedy and to exhaust that rate limit. We're still very much at the beginning of our journey with 3Scale, but we're hoping this solution will help us scale up against the increasing complexity of our shows and our pipelines. Beyond that, we still have some other things in OpenShift. So at the moment, the asset tracking system is the heavy lifting part of our system, but it's only a very small component. We've also got publishing, we've got file transfers, and these all can be moved into OpenShift. So this is our plan, and to do that, we're looking at using Service Mesh to connect them all up, and using Developer Hub to give us status for our developers on our systems. We're still only scratching the surface of what we can do here. And with that, I thank you for your time, and thank you very much.